Welcome to Math 9 in the PM. Your host, Joe Shadelka. Hot dog, we got an out of sight class, but right now we're just wrapping up 7.6 rotational symmetry. Then I'll stop this lesson and we will go mosey on into the next section, okay? And then we're wrapping up the year pretty much. So this is the last page of the whole thing. This won't take us nary a minute, okay? What is the angle of rotational symmetry for a shape with each order of rotational symmetry? Now, last Thursday and stuff when we talked about it, one full circle is how many degrees? 360. So I'm going to keep this in mind. I'm thinking 360 degrees. So if I have a shape with a three-sided symmetry, how did I get 120? I'm just putting that there. I actually forgot that I was going to twirl it, but I forgot that. How do you get 120 from that? I'll just show you what I mean here. Okay, without twirling. But that's, I'm trying not to twirl it, so I'll make a new triangle. Oh, that's that kind of triangle. I don't want that. Okay. Let's think of this. Delete. So right now I'm talking about an order of symmetry of 3. So look at this here. If I grab this shape and I spin it until the other corner is at the top, you guys follow that? I have went from here to here, right? And then, if I take that same shape and then twirl it, okay, this isn't perfectly symmetrical. Or, I mean, the center is. Okay. There you go. That means I've divided this into 3 zones. And you can use a calculator and you can't do this in your head. You go 360 divided by 3, you get 12, or 120. So that's where the answer comes from. Just the same with this 5. So if you have a 5-sided shape, like that pentagon there, like a Kaiser or something, right? You could spin it 5 times and then come back to the original spot, right? You guys do the math. You guys got calculators. You can use your phone too right now. It's not a test. What is it? How many times per swirl? So you guys follow what we're saying? Yeah. So tell me then what is the question? What's the angle of rotation for a shape with 5 spots of rotational symmetry? There's an example. Right? How do you figure that out? 360, then what? Divided by 5. My here and answer. 72. It's not a 0 or a 5, but it's still a good number. Okay, a 9-sided, a nonagon. I'm not too familiar with nonagons, 9-sided figures, but there's a picture of one. So you just divide by 9, right? Tell us what it is. You guys write in your answers for the next two, 12-sided and the 9-sided. By the way, a dodecagon is what a 12-sided figure is called. Okay? Go ahead. Put the answers inside your shapes and then we'll check answers. I make these up and then sometimes I make mistakes. So you guys better correct me. Give it a try. Potatoes and use your calculators. guys. Give me some numbers. 9-sided, what is it? Oh my God. Just half the class. Yeah. 40 degrees. And then 12 goes in nicely. And that side of the classroom. Give me a number from the back, somebody. Get your sheets out, get your calculators out, y'all. Get your sheets out. Come on. Okay, this is the exact same concept, opposite question. What's the order of rotational symmetry for each angle? Or I mean, what's the order of rotational symmetry for each angle of rotation? How many times can it fit into 360 degrees? So, the first one, A, 60 degrees. Did you know that one of these triangles, like this here, if it's an equilateral triangle, it's guaranteed to have 3 60-degree corners, okay? Look at this. So if I do it like this, 1, you guys follow this? This is order of 1. Then 2, and then 3, and then 4, 5, and over top of that, 6. Did you guys see what I just did? Like, do you guys see why I'm saying that? 6 times I could spin it around. So if I wanted to, I could create that shape. I'm using a 60-degree. So there's the first one, right? And then I say 1. And this is going to be hand drawn, so it's not going to be perfect. It gets you the idea. 2. That was really off. My pen was out of sync. 3. Okay, I've gotten off center now. 4. 5. 6. Roughly drawn. It's called a hexagon, right? And then I've come complete circle after that. Okay. But the thing is, you guys aren't able to spin diagrams and do it like this, right? If I say 60 degrees, what's the math arithmetic way of figuring out that that's a 6-sided shape and that it has 6? What do you do? Yeah, 360 divided by the angle. Yes, I'm sure you mathematically. So I'm not going to draw. The way you figure this out, though, by doing it by drawing is then, and I don't recommend it because it's going to be too laborious, is you draw a 20-degree isosceles triangle, and then you fit in how many of those, if you basically slice the pie into 20-degree slices, the corner right here is 20 degrees in the part of the pie, and then made the shape like we did over there, right? Mathematically, what does B come out to be then? 360, 20, and 18-sided shape. That's why I don't want you to draw it. Okay, now, can you guys do it for the other two? It's just a division question, but do it so that you remember it. 45 degrees, you might be able to do it in your head. And then 36 degrees. You can do that one in your head, but you can just calculate it online. It is. Hey guys, got an answer? Should. Got it down for both, right? Button what? 8 to 10, right? So essentially, that means if you divided a, I'll show it because I have the drawing with the 60 degrees. If you cut a pie into 60 degrees sections and then made the green shape on the outline. You guys follow that? That's how you could really do it. Well, if you cut 45-degree pieces, if I had a circle roughly here, then join the edges for a perfect shape. You don't have to join the edge. Even this, right? You twisted that pie 8 times, will come back to where it originally was, right? 8 times, like 45 degrees. That's what that means. And it doesn't have to be a pie shape. It's just the simplest to draw. I'm going to stop the recording. I'll upload it later.